All right, welcome everyone. Today, we are going to pull back the curtain on one of the most important building blocks in all of programming, Java methods. Seriously, if you want to write code that's not just functional, but also clean, organized, and professional, this is where it all starts.
So, does this look familiar? If you're just starting out, you've probably been there. You've written a chunk of code and hey, it works, but it's just this one long, massive wall of text. And when you have to go back and fix a tiny bug, it feels like searching for a needle in a haystack. There's gotta be a better way, right? Well, there is. Think about it like a recipe. That messy code is like a recipe written as one giant rambling paragraph. But a good recipe, it's broken down into simple, clear, reusable steps. That's exactly what methods are. They are those individual steps that bring order to the chaos and let us write truly elegant code.
So, here's our game plan for today. We're going to start with why methods are so crucial. Then, we'll dissect one to see what it's made of. We'll look at different types of methods, and finally, we'll see how to put them all together to make a program run. Let's dive in. You know, a big piece of software is a lot like a car. It isn't just one giant thing. It's built from smaller, specialized parts, an engine, wheels, doors. Methods let us build our code the same way, as a collection of clear components. They also help us follow a super important rule in programming called DRY, don't repeat yourself. Instead of copying and pasting the same lines of code everywhere, you just write it once inside a method and call it by its name whenever you need it. It's way more efficient.
So what's the official definition? A method is just a named block of code that does one specific thing. That's it. Going back to our recipe, you might have a method called chop onions or one called preheat oven. Each one has a single, focused job. That focus is the absolute key to keeping your code organized and easy to understand.
Okay, so every single method has a basic structure, which we in the programming world call its signature. Once you learn how to read a method's signature, you'll know exactly what it does and how to use it just by looking at the first line. So let's break one down, piece by piece. Take a look at this. Now, I know at first glance it might seem a little cryptic, but I promise it's just 3 main parts. And these 3 parts tell us everything we need to know. First up, we have the return type. This piece tells us what kind of information the method is going to give back to us when it's done its job. Is it going to give us some text, which we call a string, or a number, an int, or as we'll see in a minute, maybe it gives back nothing at all. Next, you've got the name. This one's pretty straightforward, but it is so important to get right. A good method name should be a verb, something active that clearly describes the one job it does. getMeAPen is a great example. You know exactly what you're going to get. And finally, we have the parameters. These are the things inside the parentheses. Think of these as the ingredients for your recipe step. If your method is chop onions, the onion itself is the parameter. For our getMeAPen method here, it looks like it needs to know the cost of the pen. All right, let's start with the simplest kind of method. I like to call this the just do it method. It's a method that performs some kind of action, but it doesn't give you any kind of result back. It just does the thing. And the magic word for these types of methods is void. Whenever you see void as the return type, it's a signal that this method is a one-way street. You give it an instruction, it carries it out, and that's the end of the conversation. No report back, no value returned. Here's a perfect, simple example. We have a method named playMusic, and its return type is void. Its only job in the entire world is to print the words music playing to the screen. It does its action, and that's it. Clean, simple, and to the point.
Okay, but that's not always enough, right? Sometimes we don't just want a method to do something, we need it to go find some information and actually bring it back to us. We need an answer. That's where return types come into play.
You can see the difference so clearly here. On the left, our playMusic method is void. It just does an action. But on the right, getMeAPen is making a promise. It's saying, when you call me, I promise I will give you back a string. It's not just doing a task, it's delivering a result. So, how does it keep that promise? With the return keyword. This line of code literally says, okay, my work here is done. Here is the string value you asked for. And it sends the word pen right back to whatever part of the code called it in the first place.
Let's add one more layer of complexity, which actually makes our methods way more powerful. Sometimes, for a method to do its job properly, we need to give it some info to start with, those ingredients we talked about. We do this using parameters.
See how our method has changed? Look inside the parentheses for getMeAPen. It now expects something, an int called cost. This means you can't just call the method anymore. You have to give it an integer when you call it. The method's behavior now completely depends on the information you give it. This makes it so much more flexible.
And now we can add some real logic. Let's trace what happens if we pass in the number 2. The method gets the input, 2. Then it checks a condition. Is 2 greater than or equal to 10? Nope, that's false. So it completely skips the first block and jumps down to the else block. And what does it do there? It returns the string nothing. Pretty cool, right? The input directly controlled the output.
Okay, now this is a really important tip, especially if you're studying for a test. The second a return statement is hit, the method stops dead in its tracks. It's over. It immediately exits and sends that value back. So if the cost we passed in was, say, 12, the code would hit return pen, and any other code that came after that if-else statement would be totally ignored. It's a hard stop.
So we've designed all our individual recipe steps, but how do we actually start cooking? In Java, the main method is our master chef. It's the starting point for the whole program, and its job is to call all our other little helper methods in the right sequence to get everything done. And here's how it actually looks in code. First, we need to create an object. Think of this like making a specific thing from a general blueprint. So we create a specific computer called obj. Then, using that object, we can call its methods with a dot, like obj.playMusic. And if the method gives something back, like getMeAPen does, we need a variable on the left side, like myItem, to catch and hold on to that result.
So let's just do a quick recap. Our playMusic method was the simplest kind. It takes no ingredients and gives no result back. It's void. Then we have getMeAPen, which is more advanced. It does take an ingredient, an int, and it does give a result back, a string. This little table is a perfect way to remember the different combinations.
And really, that's the core of it. By learning to break down huge problems into small, manageable, reusable methods, you've learned the secret to writing clean, powerful, professional-level code. You're not just a coder anymore, you're a designer. So the only real question is, what are you going to build with this new power?